what's your kryptonite? Well, for Superman, it's a green crystal produced from the remnants of his home planet, Krypton, that emits radiation. You know what? It's Superman. You're probably familiar with comic book kryptonite. But there have been recent reports that scientists have a kryptonite of their own. What's the deal with that? Well, Krypton itself isn't just a place, it's an element. The 36th element in the periodic table is a noble gas, meaning 1, it's highly unreactive like helium, argon, xenon, pretty much all its relatives on the right side of the table. 2, at standard temperature and pressure, Krypton is not a solid, nor are most of its molecular compounds like krypton fluoride and krypton hydride. It can have a crystal structure, but its melting point is 115 degrees Kelvin or -251 Fahrenheit. Plus, at that temperature, Krypton's white, not green. So, like, the kind of thing you might want to call real-life kryptonite, the crystalline form of elemental krypton, or a mineral that contains krypton, is not only not green, it's also not something you can hold in front of a guy wearing tights to sap his superpowers. I promise, no one is more disappointed about that than I am. But you have to imagine my surprise then, to discover articles in the scientific press recently about real-life kryptonite. So, what are these things talking about? It's called jadarite. The name has nothing to do with jade, but rather with the Jadar mountain range in Serbia, where this mineral was first discovered in 2004. Is jadarite green, like stock photos accompanying recent articles might indicate? No. It actually looks like this. So I have absolutely no idea how the editors justify that green crystal photo. Not exactly a high point in the history of science communication there. Jadarite's chemical name is sodium lithium boron silicate hydroxide. And you may be noticing, as I was starting to notice, that none of those names include any reference to Krypton. It isn't green, so what gives? How the heck are people getting away with calling this real-life kryptonite? Because of this. Now, I know it might not look like much, and that's because it isn't. But you will see that it is labeled sodium lithium boron silicate hydroxide with fluorine. This is a brief shot from the 2006 movie Superman Returns, which was released the year that jadarite was officially recognized as a mineral by geologists. As you can see, this sample was ostensibly found in Ethiopia as part of a palisite meteorite. Palisite meteorites themselves are a type of stony iron meteorite, and they're actually really pretty. This one, like most palisite, contains olivine, a magnesium iron silicate. But it doesn't have to be olivine in particular, just some kind of silicate. So in Superman Returns, the idea is presumably that instead of magnesium iron silicate, it's jadarite in that iron matrix there, which formed in an asteroid that then fell to Earth. So, the mineral was discovered in 2004, Superman Returns was in 2006, and you can find 2006, 2007 articles pointing out, hey, this mineral has the same formula as the kryptonite in the movie that just came out. So why is this news now, in 2025? Well, a couple of reasons. One is that it's only very recently that scientists have gotten a better understanding of how jadarite forms. And I'll let you know now, those conditions can't be found in space and then fall to Earth to end up in the Metropolis Museum's mineral collection, not even if it has fluorine, like it apparently does in the movie. Researchers have been performing experiments synthesizing jadarite in a lab, which helps us learn more about what's chemically required for its formation. After all, conditions in the Jadar Valley of Serbia are unusual but not necessarily unique, so why is this the only place that we've ever found the stuff? Turns out, jadarite can only form in the presence of lithium-rich volcanic glass near alkaline terminal lakes and with some very specific clay minerals. And synthesis experiments can show us, okay, this is at least one way jadarite can be formed, and this is what it requires, and some of these recent studies even try to determine the range of conditions in which it can form, what temperatures, and what range of alkalinity in that lake. Matching those conditions to real-life conditions, these synthesis experiments may guide exploration geologists to go somewhere else and find more of the stuff. And that's definitely relevant to industry, which is the other reason we're hearing about jadarite in 2025. Both the lithium and the boron in our sodium lithium boron silicate hydroxide can be refined from jadarite. Boron's used to make things like borosilicate glass, the heat-resistant kind used in chemistry and in vintage Pyrex. Lithium, meanwhile, is increasingly valuable globally for its use in batteries. Most of the world's lithium is refined from various types of igneous rock like pegmatite and petalite, as well as clays like hectorite. Jadar is another such source, and it is less energy intensive to refine than from some of these other minerals. So yes, one of the reasons we're hearing about this real-life kryptonite is because it is a resource in a world that is increasingly looking for lithium to power our tech, including our green energy tech, so I suppose that's the closest our so-called kryptonite's going to get to green and glow. But for research geologists, jadarite is more than what it can do for us. It's a rare, cool rock, and we're only just starting to learn more about it. And sometimes learning about rare, cool rock is its own reward. And yes, that's particularly true when it's kind of a meme rock. The mineral composition of kryptonite in 2006's Superman Returns is the most niche little detail in the world, but you know who's going to be super into that? People for whom rare, cool rock is its own reward. But come on, should we even call it real-life kryptonite? I'll be honest, when I started reading about this, the answer was going to be a resounding no. Doesn't emit radiation, doesn't weaken superpowers, doesn't glow green. In fact, it's not green at all. It doesn't even have krypton in it. But no, it's not called kryptonite for me. It's for the little rock nerds who know the formula from like a 2-second shot in an unevenly received mid-2000s Superman film. That is for the geologists and the geologists alone. And you know what? Go for it. Enjoy your kryptonite, geologists. Rock on.